To our next lesson on combining transformations. So last class we learned how to read vertex form for a quadratic equation. We're going to use that same sort of principle to do this by having more than one transformation at a time. So last class we either just moved up or we moved our parabola to the left or right, or we stretched a compressor graph. Now we can have a parabola that has been stretched and been moved up by 2. And this is our first question. Because this whole number is larger than 1 in front of the x squared, we know that our graph is going to look skinnier. And we're going to shift our graph up by 2. We can also determine our vertex from here. There's nothing inside of this x, and there's no brackets around it, so we know that our x value for a vertex is just 0. But this 2 on the outside of the x squared, this is our y value for the vertex, and that is 2. So we have a vertex at 0, 2. To find the next point, we can use a table of values. So we can look at x equals 1, and if you want, even x equals 2. Okay, so that's 2 times 1 squared plus 2, just by plugging the 1 back into the 2x squared plus 2. So that's 2 plus 2, which is 4. Then if you want to find the next point, we're going to do 2 times 2 squared plus 2, again putting x equals 2 into our original equation. That's 2 times 4, which is 8 plus 2, and that's 10. So our y value 10 will go beyond the graph, so we can just maybe graph the 1, 4. And we know that our parabola is symmetrical, so if I have a point at 1, 4, I'm also going to have a point at negative 1, 4. Then we'll connect our points, extend a little bit with an arrowhead, and that is our graph. So your domain is the same for all parabolas, negative infinity to positive infinity. Your range in this case is 2 to infinity, and we can touch that 2 because that is our lowest y point. Your axis of symmetry is the x value of your vertex, which is 0. Here we have a minimum. If you take a look at our vertex, and this occurs at x equals 0. We don't have any x-intercepts. We will never cross the x-axis. And your y-intercept is at 2, because that's where we cross our y-axis. Okay, let's do another one. We can determine the vertex right away. So this is going to be a negative 2 for our x value in the vertex. The general rule to make it easier for you to find the x value is to take whatever number you see inside the bracket and then have the opposite sign for our value of x. So instead of saying positive 2, say negative 2. And that is only for the x. When you read out your y, you're going to include the sign with it. So your y value for your vertex is negative 1. So our first point is at negative 2, negative 1. And then we can go ahead and find the next point. I'm just going to choose negative 1 and 0. Could you have picked other points? Certainly, but I'm just picking the one that's kind of next to our vertex. So I'm going to plug in negative 1 into our original quadratic function. So that's negative 1 plus 2 squared minus 1, which is 1 squared minus 1, so that's 0. So that's our next point, is at negative 1, 0. Then we can find the one for x equals 0. So that's 0 plus 2 squared minus 1, which is 4 minus 1, and that is 3. And you know it's going to occur on the other side of your vertex. So we're going to have a point at -3, 0, and at -4, 3. We connect our points, extend a bit, add the arrowheads, and that is our graph. Your domain stays the same. Your range in this case is -1, that's our lowest y value, to infinity. Your axis of symmetry is always the x value of your vertex, which is -2. In this case, we have a minimum. It occurs at x equals 2, -2. Your x-intercept, we have it on this graph, is at -1 and -3. And your y-intercept is at 3. Okay, for our next graph, we have 3 transformations now. But again, we can start off by reading off the vertex. So your vertex is going to be -3 and then +2. You can graph that first. So that is your vertex. What this -2 tells us is that we're going to have a skinnier looking graph, a more narrow looking graph, and also the negative means our graph is going to be upside down. So we'll take that in consideration, but we can still do a small table of values on the side to help us out. So we can pick the next point over, we can pick -2, and we can also pick -1. So I'm just going to plug in the x equals -2 back into our original function. So that's -2 plus 3 squared plus 2, which is -2 times 1 squared, which is just still 1. That means we have a point at -2, 0. We can do it for x equals -1 now. -1 plus 3 is 2. Two squared is 4. -2 times 4 is -8, so this is -6. So we have a point at -1, -6. And then on the other side, we know it's symmetrical, so we're going to have a point at -4, -2, as well as -5, -6. And that is our graph. Our domain is the usual, -infinity to +infinity. Our range, if you look from bottom to top, our arrows are pointing down, so our left side is going to be -infinity for our range, and then it's going to go up to 2, because that is our highest point for our y value, and we are going to touch it. Your axis of symmetry is going to be the x value of your vertex. You have a maximum in this case because we have a highest peak point from our vertex. This occurs at x equals -3. Your x-intercepts are -2 and -4 according to our graph. And the y-intercept we need to find. So in order to find our y-intercept, we're going to set x equals to 0. So that's -2, 3 squared plus 2, which is -2 times 9 plus 2. It's -18 plus 2. That's -16. So that is our y-intercept. So in order to set x to 0 whenever you need to find the y-intercept. I'm going to do one more graph. Again, the first step is to find that vertex. in this case is going to be positive 2 and negative 3. So our x value is 2, y value is negative 3. And we can graph that right away. And the other information we have is this a half at the very front. This means we're going to have a wider looking graph. And we're just going to keep that in mind when we're drawing a graph. We can do a small table values on the side to find the next point. Let's do 1, and we can even do 0. I'm going to plug this in to find our y value for our x equals 1. Right, so this is going to be 1 squared, which is still 1, so it'll be a half minus 3. Or in other words, 0.5 minus 3 is negative 2.5. Then for 0, it's going to be a half times 0 minus 2 squared minus 3. So that's a half. 2 squared is 4, and that negative is going to be gone as well because that's negative times the negative. 4 divided by 2 is 2, so I have a point of negative 1. So I'm going to graph that. 1, negative 2.5, and then 0, negative 1. And then we know symmetrical, so we're going to have the same sort of points at 3 and 4. So at 3, my y value will be negative 2.5, and at x equals 4, I'm going to have a y value of negative 1. So that's what your graph is going to look like. The domain remains the same. Your range, your lowest y value is negative 3. When we touch it, and it goes on to infinity. Your axis of symmetry is going to be 2 because that is the x value of your vertex. We have a minimum here at x equals 2. Our x-intercepts we do need to find. I'm going to just do it down here. And we're going to set y equal to 0 to find our x-intercept. So I'm going to move the 3 to the other side. And then multiply both sides by 2 to get rid of the half. So if I multiply both sides by 2, I'm going to have 6 then, because that's 3 times 2. My half is gone. Then I'm going to square root both sides. So the square root of 6 is equal to x minus 2. Remember, when you square root something, this becomes plus or minus. Then lastly, I just need to add 2 to both sides. So our x-intercepts are plus and minus negative 6 plus 2. I'm just going to leave it like that. If you had a calculator, yes, you can go ahead and punch those numbers in to figure out what your 2 x-intercepts are. For your y-intercept, we're going to set x equal to 0. And if we have a 0, then I'm just left with negative 2. Negative 2 squared is positive 4. 4 divided by 2 is 2. Minus 3, this is negative 1. And that's exactly what we had on our graph. All right, so for example 2, we want to write the equation of the quadratic function given only the properties of their graph. So we want to get something of this form, given that we know what the vertex is and we know what the other point is. So we're going to make sure that our equation is in the form of y equals a x minus b squared plus c. We can tell what B and C is right away because we were given the vertex. This is going to be our B value. This is going to be our C value. Now we just need to find A. So from here to here, we plugged in the vertex. And then now we want to find C. Sorry, we want to find A. We already have C. And we're going to do that by using the point 3, 4. Because this is an X value and this is our Y value. So instead of writing Y is equal to, I'm going to say 4 is equal to because that's a Y value. I don't know what A is, so I'll leave it alone. My X value is 3. And I'm going to go ahead and simplify and solve for A. So 3 minus 2 is just 1, and 1 squared is just 1, so I'm just left with A. Then I'll subtract 1 on both sides. So 4 minus 1 is 3, and that's our A value. Now I'm going to put it together. So Y is equal to 3x minus 2 squared plus 1 is our final answer. So again, your first step is to plug in the vertex. Your second step is to find A. Your third step is to put it together. Let's do another example, but we're given a different type of information. So for this one, we're given the axis of symmetry. The only thing I can really plug in right away then is the B value. And if I simplify that, this is going to be x plus 1 squared. Okay, so we also were given two pieces of information. The graph passes through 0, 3 and -3, 9. So what I'm going to do is utilize both points, but one at a time. And I am going to create two equations, and then we need to solve it by using systems of linear equations. So for the first one, I'm going to plug in the 0, 3. 0 is my x value, 3 is my y value. I still don't know what c is. Now I'm going to just simplify this a bit. Okay, so that's what we have. Now I'm going to do the same thing for our second point. Just plug in our x and y value. So our y value is 9. Leave the a alone. Then we have -3 plus 1 squared plus c. And then we want to simplify that. So -3 plus 1 is -2. Then we want to square that -2, so that's 4. And that's what we have here. So we're going to use system of linear inequalities to solve for it. We have two different variables. I'm just going to rewrite this one here from 1, so I can say that a is equal to something. If I move c to the other side or subtract both sides by c, I get 3 minus c is equal to a. I'm going to put equation 1 into equation 2. So that means I'm going to put in 3 minus c in for my a into the second equation. So this is the second equation, and I'm going to put in 3 minus c. Because now I only have one variable to solve for. So we're going to go ahead and simplify this. That's 4 times 3, which is 12. 4 times -c is -4c. I'm going to combine my like terms. So I'm going to subtract both sides by 12, which is -3. -4c plus c is -3c, so c is going to be 1. Then I need to find d. So I need to find A. So that's 3 minus 1, because I just found C was 1. So A is 2. Now we put everything all together. Y is equal to 2, because that's my A. X plus 1 squared, because that's what I got in the first step. And now my C is 1, so plus 1. So that is our final answer. In example 3, we were given the graph, and we want to find the equation. So the first thing I can do is read off for my vertex. We have a vertex at 5, negative 4. And I can look at a next point and record that. So this next point can just be 2, negative 1. And then we're going to solve exactly like how we did in example 2a. So if you look at example 2a again, we were given a vertex and we were given that point. So the only thing different is that I'm going to read off the vertex off the graph and find another point on the graph and do the same sort of thing. So I'm going to put in the vertex, x minus 5, minus 4. Okay, then I'm going to use that second point and plug it in for my x and y so I can solve for a. So y is negative 1, x is 2, and then we're going to simplify this and solve for a. So 2 minus 5 is negative 3. Then we're going to square the negative 3, which is 9. Okay, so from here we're going to add 4 on both sides. So that means I'm left with 3 on the one side. Now we're going to divide both sides by 9. So a is 1/3 after I simplify that fraction. Now we're going to put it all together. Y is equal to 1/3 because that's our a. X minus 5 minus 4. For b, same sort of thing. We're going to state the vertex, which is 0, 3. And then you find another point. Doesn't matter which one you use. You'll still get the same a value. But I'm just going to use this one, which is 1, 1. So go ahead and try this one on your own. You have the vertex, you have a second point. Try to find the a value and then put it all together to find the equation. All right, so for this one, we don't have an x. So you could say x minus 0 plus 3, but that's the same thing as saying ax squared plus 3. Now we can just plug in our 0.11 to find our a value. So then we're left with 1 is equal to a plus 3. Subtract 3 on both sides. A is negative 2. So putting this all together, y is equal to negative 2x squared plus 3. Our last example, example 4. We want to determine the number of x-intercepts just by reading this, a and q. So the a has to do with this number here, and q has to do with the second ones. We just want to know the number of x-intercepts. We don't need to know what they are. So what you can do is just draw a really rough sketch of the graph and then determine it from there. So for this one, we know that we have a minimum because we have a positive a. We also know that our vertex is going to be below the x-axis, so we're going down by 3. So our vertex can be anywhere along here. We can just say it's this one. Because we know the x value is 0, so this would be your vertex. then we know that the arms are going to face up because we have a positive number in front of our x squared. So according to this rough sketch, we are going to have 2 x-intercepts. For our next one, our vertex is going to be 1, 0, because we have nothing here. And we're going to take this number, which is going to be the x value of our vertex. And then we'll look at the 2, and the 2 is positive, which means that we are going to have arms that face up. So according to this rough sketch, we are going to have 1. And then lastly, we're going to pick up the vertex from here. So your vertex is going to be -2, -1. So somewhere here. And then if you look at our a value from the very front, it says -3. So this -3 means that our arm is going to face down. You have an upside down parabola when that a value is negative. And it looks like we won't have any x-intercepts here, so that's none. So again, for question 4, just read off the vertex, determine where your arms are facing, either if it's up or down, according to if your a value is positive or negative, draw a rough sketch of it, and then you can determine the number of x-intercepts.